STM32 development boards are very powerful and versatile little boards, but setting them up can be a little tedious, especially if you use Linux. In this tutorial, I will show you how to set up their development environment using VSCode and the Platformio extension. ST Microelectronics, the company that makes these boards, does provide a fully featured IDE and some other tools like CubeMX, the board initializer we will use today to help in our development. But in my experience, their IDE is not that comparable to VS Code if set up correctly, that is. A little disclaimer before starting. Installing packages varies from distribution to distribution, and of course I cannot show you guys all of them. I'm using Ubuntu 20.04 for this tutorial, but if you are using a different distribution, I will provide some links in the description for you guys to follow. But other than that, the setting up process will be similar. So let's get started. Open your favorite browser and Google VS Code and click the first link. Click the appropriate download button. In my case, that will be this one. Wait for it to download. Bring up your terminal, cd to downloads, ls, and install VS Code. Wait a little bit. Done. Now open up VS Code. And I'm just going to make it a little bigger. Click the extensions button and search Platformio. Hit install and wait for it to download. Now depending on your internet connection, it can take some time, so be patient. Okay, I'm just going to cancel that and minimize VS Code. Go to your browser again and search for CubeMX. Again, open the first link. Scroll down. Hit get latest for the Linux version. Accept. And now log in. This is very annoying, by the way. If you don't have an account, create one. I already have an account, so I'm just going to log in. It takes a bit to load, but your download should start. There we go. When the download completes, minimize the browser and open your terminal again. And type sudo apt install default JRE and hit yes to install the Java runtime environment. Wait for it to download and install. Okay. I'll clear up the terminal. cd downloads ls. I will unzip CubeMX, ls again, and just run the installation script. A GUI will open. Just hit next. Accept the terms and conditions. Next again. Yes, I have read the privacy policies. Not really. Next. Now this is the important bit. Make sure your path is set to home username STM32 CubeMX. Hit next. Wait for it to install. Next again. And finally, done. So by now you have installed 3 programs: VS Code, CubeMX, and Java Runtime. In a little bit I will explain how they all work together. For now, I'll just clear the terminal, and oh, before that, open up your file manager and navigate to your home directory and make sure your STM32 CubeMX file structure looks like this. And for convenience, I'll just make an alias so I can open CubeMX directly from the terminal. To do that, type nano home/.bashrc and paste this in there. Ctrl S to save, Ctrl X to exit. Source bashrc, and now I will just type CubeMX, enter, and boom. But for now, I will Ctrl C to close it, clear up the terminal again. For all of this to work correctly, you need to install one more piece of software. It's a script basically that ties all of this together. The GitHub link will be in the description. Before we install it, make sure you have pip3 installed. To check that, just type sudo apt install python 3-pip. Hit enter and let it install. Now type pip3 install STM32 PIO. No, sorry. Clear up the terminal and type sudo pip3 install STM32 PIO and make sure it is installed correctly. Type STM32 PIO and hit enter, and you should see an output. So what we have installed so far are all different components that work together to create a Platformio project for our dev board. This graphic provided by the same person who created the STMPIO script illustrates this well. CubeMX provides a user-friendly GUI for us to configure many features the STM32 dev board family provides, and auto-generating their initialization code so we can strictly focus on utilizing them. But CubeMX spits out a file format VSCode cannot understand. This is where STM32PIO comes in. It looks at the config file and converts that into a Platformio friendly project file. Lastly, we will open the project file in VSCode and use the Platformio extension to flash our dev board. Now let's set everything up. For neatness, I'm going to make a separate directory in my home to keep everything organized. Bring up your terminal and type make directory dev cd dev make directory CubeMX and clear the terminal. Now run CubeMX, wait for it to open, click here. Now a new window will open. From here you can search for your MCU. But since I already have the dev board, I will just click on the top corner board selector and search my board from there. For this tutorial, I'm going to use the STM32F3 Discovery. I will click this little star to add it to my favorites, and on the top right corner, click Start Project. Hit yes to initialize all the peripherals with their default mode, which basically means CubeMX will use the board's factory config to set its clock, a few pins, and some other things for you so you can quickly flash a demo program on it. There we go. Let me just make this bigger. Here you can see the MCU's top view. You can zoom out and zoom in. And here are the output pins CubeMX set for us. I will just rotate them so you guys can see them easily. You can change them of course, but for this tutorial I'm going to leave them as is. Okay, let's move on. This is the clock configuration section. Here you can change all your peripherals, well, clock. But for this tutorial I am going to change the main hardware clock to 72 MHz, which is the max frequency of my MCU. If you want a deeper dive on this section, leave a comment below. Next is the Project Manager tab. Here we need to change some settings. First, give your project a name. I will name it STM32 Blink. Tell CubeMX where the project is saved. Hit the browse button and I will save it to the dev CubeMX directory I created previously. Set the application structure to basic. Set the toolchain to other toolchains. Next, click the Code Generator tab. Here set this to copy only the necessary library files. And take Generate Peripheral Initialization as a source and header file pair. This just keeps all the peripheral files separated and easy to debug. And the next tab just shows all the peripherals in use. Now look at the top of the program. Hit Ctrl S. Untitled will change to the project name. When that's done, minimize CubeMX and open VS Code. Platformio is installing. I'm just going to let it finish and restart VS Code. Click the small home icon at the bottom. I'm just going to do Ctrl tilde to remove the terminal for now. Now this is very important, so pay close attention. Hit the boards icon and search for your dev board. I think for all ST branded boards you have to type ST first, then the board name. So in my case that will be STM32F3 Discovery. When you find your board, expand it and copy the board ID. In my case that's disco underscore F303 VC. Now do Ctrl tilde again to open the terminal. Navigate to the directory where you have saved the CubeMX project and cd into it. In my case that will be cd home / dev / cubemx / stm32 blink ls. Now type stm32 pio new -b. Ctrl Shift V to save your board ID -- with -build. And fingers crossed, if God is on our side, it will build. It may download some libraries like it is doing here. Okay, it built successfully. Now just open your project in VS Code, hit the Explorer button and simply navigate to your project. Okay, yes, I trust this folder. Here are all the peripherals separated in their own files. This is the main.c file. We will write our code here. And all this extra stuff is all CubeMX generated, like setting the clocks, initializing all the peripherals. Without this, your dev board will not work, so do not delete anything. Now let's try to flash our board. Oh, before that, open your platformio.ini file. Here is where you specify your upload device, add libraries, change baud rates for your serial monitor, etc. Okay, now let's flash our board. I don't have the ST-Link drivers, so I don't think it will upload, but let's see. Yeah, just install the ST-Link tools package and restart UDEV. wait for it to download, and install, and replug the board. Let's try it again. Okay, great, it works. Now on different Linux distros, you might have to create a udev rule file or install some other package. From my experience in this last stage, getting your code to upload takes a bit of googling. In the description below, I have some links for you guys to follow if you get stuck. And that's all. If you liked this video, consider leaving it a like and subscribing. Bye.